Yeet! Welcome back, explorers of the internet. It's late Monday, and you know what that means. I could not stream previously this week due to an emergency, which is why I've added the things that I've added right now, and don't know if it works, so I'm gonna have my accomplice here test it out. You here? Come on. You here? Hello, hello. Oh, seems that it does not work. It did not work. We gotta fix that. Why does it not delete the text? Where is it? Here it is. Let's try that again. Test. Don't know if that works. The filters are not working. What if I put timeout lens to 1? Now do it again. Okay, that did not work either. Is it because I didn't make the bot a moderator? I thought I did. Hang on. How do I make the bot a moderator? Because the filter is on. I don't see any options. Just gonna do a few quick Googling. Forgive me for a moment. Go to the channels page and use a command. Huh? Oh. Mod stream elements. I don't have permission. Oh, right. Need to log in first. Let's try that again. And nothing. Go for it. Ooh, okay. Okay, that was nice. Why did it get deleted twice though? That's kind of weird. Oh. And mine still works? Yeah, mine still works. Perfect. Right, you might have caught on to what this new feature is. If you do /w or /whisper, then the bot will repeat your message. And it will not show up in chat. It will show up right now because I'm the one typing it. The bot cannot delete my message. But if I have someone else type it for me. Oh, he's gone. Can you try the command real quick? And I do not see the message. This essentially means you can send messages to everyone else in chat except for me. I hope this feature won't be needed, but I may have seen some things I shouldn't have. And if worse comes to worse, I feel like we might need it. But enough with that talk. Let's get back to the main course of the meal, which is... Oh yeah, real quick, I added another command called Minecraft. It gives you an IP address. Oh, do not click it if you want the link. It sends the link in chat, you just copy paste it into Minecraft. It's a link to the Minecraft servers that I was working on. Hang on real quick. Where's... Huh? Oh. Give me a second. All right. Now let's see. Today, it's a little bit past midnight. My brain is still working pretty close to peak capacity. Therefore, today we have parametric curves and polar curves. We got a 3-unit course to work through. And my god, does it look like there's gonna be a lot of graphing. I hate graphing. I'm sorry, I just hate graphing. Especially, I think it's easier when you have a whiteboard like this. It's a lot easier to draw. But it seems like 10.1 is exclusively about graphing parametric curves. One wants to know, or it wants you to graph x is equal to 1 minus t squared and y is equal to 2t minus t squared. Feels like I stopped writing for 1 week, my handwriting suddenly deteriorates to a doctor's. And it goes from -1 to 2. T goes from -1 to 2, inclusive. So, how am I going to draw a straight line when they don't let me use a ruler? Will it turn it into a straight line for me? Doesn't seem like it. Oh, if I hold down shift, it draws a straight line. Okay, this is pretty awesome. Hold down shift, draw a straight line. Oh yes. Now then, can't really tell what this curve is. Best I could probably do is plug in points. So at -1, x is equal to 0. No. Yeah, when t is equal to -1, x is equal to 0. And y is equal to... No. Y is equal to 1. Let's say this is 1. This is 0, 1. when t is equal to 0, x is equal to 1, y is equal to 0. Okay. When t is equal to 1, x is equal to 0, y is equal to... Wait a second, no. Where did my algebra go? When t is equal to -1, y is equal to -3. 1. I probably should have graphed it better. Let's say that's 1, 2, 3. So it's 0, -3, 2, 1, 0. And when t is equal to 1, x is 0, y is 1. When t is equal to 2, x is equal to -3, and y is equal to 0. Let's call this 1, 2, 3. So by the looks of it, it probably goes like this. Come on, I just want a smooth curve. Oh no, the perfectionist in me is speaking. Come on. Come on. Symmetrical. Yes, just like that. So it's like a rotated parabola. And just to test things out real quick, if x is anywhere... Wait, no. As t increases, x goes up and then down. Y goes up and then... Wait, no, yeah. Okay, this looks pretty correct. Let's draw some arrows to indicate the way that the curve's traveling. Yeah. This is x, this is y. Let me actually just put down some legends real quick. This is 1. This is -1, this is -2. -3. -1, -2, -3, 1. So this is most likely how it's gonna look. So next up we got number 2. Number 2, wait, no, number 3. Skip number 2. Number 2 has x is equal to t plus sine of t. Oh no, my pluses are looking awfully similar to my t's. Let's put a little hook at the bottom of the t. Plus sine t. And y is equal to cosine t. T is between -pi and pi, inclusive. Hold down shift, draw the Cartesian plane. One unit longer. And that's fine. It's in here, draw another line. Oh man, my lines are terribly not very symmetrical. The top is a bit longer this time. Let's see. If t is -pi, then x is -pi. Let's say this is 1, 2, 3. So start at -pi and -1. Yeah, I got a cosine negative pi or cosine pi is just -1. So negative pi, -1, somewhere around that. And then what do we plug in? 0. If we plug in 0, x is 0, y is 1. And if you plug in pi, it's basically flips over. So this is going to be symmetrical. Because is it going to be symmetrical? I think so. Yeah, because t goes from negative pi to pi, sine of t goes from 0, no, it goes from 0 to, what was I trying to say? Goes from 0 to power 2, yeah. Not power 2. What was I saying? I don't know what I'm talking about. Okay. Plugging a couple more points in between. If pi is, no, if t is equal to pi over 2 or negative pi over 2, if it's pi over 2, then that's pi over 2 plus 1. Pi over 2 plus 1 would be about here. And cosine y would be equal to 0. So 3.14, that's about 1.6, about 2.6, about right here. Plug in negative pi over half, you get negative pi over half minus 1. So it is symmetrical. About right there. This is looking kind of like a parabola. Looks like a parabola to me. It's gonna be a wide one. Come on. Just let me draw a curve. And yeah, okay. Not gonna worry too much about it. And it travels this way. Next up, we got number 5. Number 5 has x is equal to 2t minus 1 and y is equal to 1/2 t plus 1. Let me put my little hook under the t's. And this time it says first sketch the curve using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases. And B is eliminate the parameter to find a Cartesian equation of the curve. So we got 2 parts this time. Is that a straight line? Looks like it to me. Why does it just never look straight? It looks like the top is longer by a unit again. Damn it. X is equal to 2t minus 1, y is equal to 1/2 t plus 1. So every time t increases 1, x increases by 2, y increases by 1/2. They start at -1 and 1. So it starts right here every time x goes forward by 2, y goes up by a half. So 1, 2, 3, 4. Every time x goes forward, y should go up 1. And can I draw this line? Hold down shift. I'm gonna cheat. Look at this beautiful straight line. Oh god, how am I gonna draw this side? Okay, this is fine. And it goes this direction. Now for the second part. Well, t is going to be equal to x plus 1 over 2. Therefore, y is going to be equal to 1/4 x plus 1 plus 1. Plus 1? No. Wait a second, did I do something wrong? T equals to x plus 1 over 2. Y is equal to 1/2 times that, so that's 1/4 x plus 1. But if t is equal to 0, y is equal to 1, and x is equal to -1. Oh yeah, this is correct. This is correct. So we have -1, 1. This is perfectly fine. So we got overall y is equal to 1/4 x plus 5 over 4. And there's your Cartesian equation. Next up, number 7. Number 7 says x is equal to t squared minus 3, and y is equal to the little curve here, t plus 2. And it goes from -3 to +3 inclusive. Graph first. 1. Wait, no, that's not full unit. 1, 2, 3, 4, 5, 6, 7, 8. And middle across. There's a good Cartesian plane. No. What did I just write here? Less than t, 3. We plug in -3. Actually, ain't gone. Plug in 0. I think plugging 0 is first would be a better idea. Plug in 0, we get -3, 0. No, -3, 2. What am I talking about? -3, 2. Plug in 1 or -1, x would be... Okay, so this is a horizontal parabola. And t would be 3 or 1. Plug in 2, we get 1 or 1, and y is gonna be 4 or 0. So this is just a horizontal parabola. Plug in 3 and x would be equal to 6. That's about here. And y would be 1 greater and 1 lesser. About here. And curve would go this way. That looks like an ugly parabola, but I can't help it. So on to the equation part. We should probably solve for y. So t is going to be equal to y minus 2. Therefore, x is equal to y minus 2 squared minus 3. You know what? That's good enough for me. This is enough to tell that it's going to be a horizontal parabola that starts at negative 3, 2. Don't bother simplifying unless it's necessary. Now, number 9 has the equation x is equal to square root of t and y is equal to 1 minus t. And t, no, there's no limit on t. So here, let's graph. I can kind of already guess what this graph is going to look like. God, that is not perfect. I think this is better. Ah, I messed up the units again. Now the top is 1 unit longer. Okay. It would probably be easier to find the Cartesian equation first, but oh well. Plug in 0. Y is equal to 1. X is equal to 0. Can have negatives. So t has to be greater than or equal to 0. Plug in t equals 1. X is 1. Y is 0. Plug in 4, x is 2, y is negative 3. Okay, this is half a parabola. This is just half a parabola. And if you solve for it, y is going to be equal to 1 minus x squared. And x has to be greater than 0. Greater than or equal to 0. There we go. Next up is number 11. Number 11 says x is equal to sine of 1/2 theta, and y is equal to cosine of 1/2 theta. And theta is going to be between negative pi and pi. So we got sine and cosine for x and y. That's going to be a circle. It's going to be some sort of a circle, or something round at least. And there's two parts. A says eliminate the parameter to find a Cartesian equation of the curve, and B sketch the curve and indicate with an arrow in the direction that the curve travels. All right, part 1 first. But hang on. Square both sides. X squared is equal to sine squared 1/2 theta. Y squared equal to cosine squared 1/2 theta. And sine squared 1/2 theta plus cosine squared 1/2 theta has to be equal to what, right? Yeah, hang on. Where does the 1/2 come in? Plug in negative pi. negative pi, and we get wait, I think I understand. If we have 1/2 here, that's gonna be half of a circle. So we go from sine of negative pi over 2 to positive pi over 2. Why did I write theta here again? Which means it's gonna look like the top half of a circle, because cosine never gets to the negative part. So we have x squared plus y squared is equal to 1. And y greater than 0. Let's just put it here. Y has to be greater than or equal to 0. Now for the graph, that's easy. Just draw a little graph right here. Come on, straight line, straight down. It's gonna just be a half a circle with a radius of 1. Circle, 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 round. There we go. And it goes this way, because x goes from negative to positive, therefore sine of that thing goes from negative to positive. And that's 1, negative 1, that's 1. Should probably be labeling my axes. XY, 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 XY. All right, number 15. Do the same thing, except this time x is equal to t squared and the y is equal to natural log of t. Okay, so t has to be greater than 0, and therefore x has to be t has to be the square root of x. It would be the square root of plus or minus x, except t has to be greater than 0. Hello, Robot Socks for 1. Oh yeah, another thing I did is I enabled the notification we have a follower in chat. Well, there's a notification for a lot of things that happen in chat now. Let's see, where was I? Oh yeah, parametric curves. Therefore, we get y is equal to the natural log of the square root of x. So that's gonna be just a plain old natural log curve. Come on, give me a straight line. Give straight line. And y is equal to natural log square root of x. So if x is 1, y is 0. It goes down this way. Goes up this way. And the curve travels in this direction. Label axis xy. Okay, that wasn't too bad. That's 1 right there. This is a regular natural log curve. But next up, particle problem. Next up is number 19. All right, box answer. X is equal to 5 plus 2 cosine of pi t. And y is equal to 3 plus 2 sine of pi t. I can already tell this is going to be a circle. And then t is between 1 and 2 inclusive. So it says that describes the motion of a particle with a position xy as t varies in the given interval. I think it just wants a graph, because what better way to describe the motion of a particle than with a graph? And it's gotta be a perfect Cartesian plane. Damn, I messed up the units again. Start here. 5, 1, 2, 3, 4, 5. This has to be good, right? This has to be good. Draw horizontal one. Ah! One longer, please. There we go. There we go. Now, this is X and Y. This has to be a circle. Plug in 1, or rather, you plug in 1, we get 3. X is equal to 3, and Y is equal to 3. 3, 3. So this is where we start. Plug in 2, and we get 3, and wait, no, plug in 2 will get 7. Is it 7? It's 7 and 3. 3, 1, 2, 3, 4. Right here, 7, 3. What if we plug in 1/2? That would be 3 pi, cosine of 3 pi over 2. Which would be... Wait, it would be right in the middle here. It has to be in the middle. And if we plug in 1.5 for t in y, we get that's -2. We get what? I see. So it would be a semicircle that looks like this. Hello, Kuya Johan. How's your morning? Do I know you? I might do. Oh my god, I'm terrible with names. I cannot remember anything. Yeah, I don't remember names. You want me to memorize complex passwords and mathematical theorems? Fine, just don't make me try to remember a name. Anyways, talking the facts of SpongeBob bomb. Wait, what? Hang on. It said first time chat from viewer. It said first time chat from viewer for you. So you haven't introduced me to the culture of SpongeBob bomb yet. I need to know, what is a SpongeBob bomb? The particle moves in a semicircle. like the graph. Oh yeah, the theory, right? How SpongeBob was actually about nuclear testing. And they somehow created these underwater creatures. A living sponge and a sentient starfish. I remember now. The SpongeBob's conspiracy theory. Now, how much space do I gotta leave? Oh, we're pretty good on space. But after 10.1 is 10.2. 10.2 is calculus with parametric curves. Has 23 nuke bombs on a Bikini Atoll. Oh god. Let me write the title really quick. Calculus with parametric curves. 23, that's a very specific number though. How do they know that there was 23 nuclear bombs being fired? I thought it was a children's show. 10.2 starts with question 3, which says find an equation of the tangent to the curve at the point corresponding to the given value of the parameter, and our curve is x is, I finally don't have to graph anymore. I'm pretty happy with this. X is equal to t cubed. Let me put a little curve on t plus 1, and y is equal to t to the power 4 plus t. And we want to find the slope at t is equal to -1, or rather we find the tangent. So the slope has to be whatever slope this equation has at t equals -1. So dy dx is equal to 4t cubed plus 1 over 3t squared. And this has to be equal to -1. Oh, wait, no. Oh yeah, -1. Kind of forgot my algebra. When is this equal to -1? If we plug in -1, yeah, if we plug in -1, that's -4 plus 1, -3 over 3. Wait, no, what am I doing? We plug in t is -1. Yeah, I did it right. So dy dx at t is equal to -1 would be equal to -1. So now that we have a slope, we want the initial point. If t is -1, x is equal to 0, y is equal to 0. Okay, so our equation would simply be y equals -x. Oh yeah, I forgot to check my answer for all of the previous questions. Actually, I don't think I do have to. It's all graphs. It's all graphs. You know, 10.1 was a really easy unit. 10.2, however, has to do with calculus again. Number 3 is y equals -x, which is perfect. And number 5 is x is equal to t cosine of t, and y is equal to t sine of t, and t is equal to pi. So we start at plugging pi, we get -pi Plug in pi, we get 0. Negative pi 0. We start at negative pi 0. dy dx is going to be multiplication rule. So sine t plus t cosine t over negative sine t. Wait, no. Cosine t minus t sine t. Plug in pi, we get 0 plus negative pi over -1, which is pi. So we would have y equals to pi of x plus pi. Is that right? Pi x plus pi squared. Yeah, same thing. Now, moving on to number 7. 7 says x is equal to 1 plus natural log of t, and y is equal to t squared plus 2 at coordinate 1, 2, 1, 3. Find an equation of the tangent to the curve at the given point by 2 methods. Or no, we only do A. So we do this without eliminating the parameters. Okay. If x is equal to 1, t has to be equal to what? And dy dx is going to be equal to 2t over 1 over t. So 2t squared, which is 2. Yeah, I think that's fine. Therefore, we have y is equal to, or rather, 1 minus 3 is equal to 2 times x minus 1. Wait, yeah. So y is equal to 2 times x minus 1 plus 3. 2x plus 1. Yeah, same thing. I'll just rewrite it to be simpler. It's number 7. Next up is number 13. 13 says x is equal to e to the power of t. Y is equal to t times e to the power of negative t. Ugh. Find the first derivative and the second derivative, and then for which value of t is a curve concave up. It's starting to get difficult. So dy dx is equal to, chain rule, we get e to the power of negative t plus t, or minus t times e to the power of negative t divided by e to the power of t. And that's going to be e to the power of negative t times 1 minus t over e to the power of t So that's just 1 minus t over e to the power of 2t. Okay. I think I would be more comfortable if I write it a different way. How about e to the power of negative 2t times 1 minus t? Or even better, never mind, this is best, this is good. And then we get d squared y dx squared, right? Is that how I write it? Where's the question? Yep. This is equal to, oh, how do I find the derivative of this? Negative 2 e to the power of negative 2t times 1 minus t minus e to the power of negative 2t. Yeah. Over e to the power of t. And that's gonna be... How do I simplify this? Take out e to the power of negative 2t times negative 2 times 1 minus t minus 1 over e to the power of t. So that's negative 2t minus 3 over e to the power of 3t. Is that algebra right? Okay, what does the question want? Oh yeah. So this is d squared y. Let me just circle this. Or actually, no. dy dx is equal to 1 minus t over e to the power of 2t. d squared y dx squared is equal to 2t minus 3 over e to the power of 3t. E to the power of 3t is always positive, so when t is greater than 1.5, when t is greater than 2 over 3, no, wait, what else is it? 3 over 2, because the top would be positive. Let's see, this is number 13. That everything on a single line. But it looks to be correct. Looks long, but these problems so far are all pretty easy. Next up is number 15. 15, we do the same thing, except this time x is equal to t minus natural log of t. And y is equal to t plus natural log of t. Looks about right. Now then, dy dx is equal to, or rather, let's do this separately. dy is equal to 1 plus 1 over t. dx is equal to 1 minus 1 over t. So we already know what dy dx is. dy dx is equal to 1 plus 1 over t over 1 minus 1 over t. Oh god. Algebra time. How do I simplify this? I hate looking at this. What can I do? The fact of Frozen, how Elsa frees an entire kingdom, that one. Is there also a conspiracy theory for that? Because I know Disney always does these terrible things and put these in kids' cartoons. But I don't know any conspiracy theory about Frozen. Walt was frozen before the movie. Walt Disney? Yeah, they're the same company, right? Oh god. Walt Disney was a person, right? Was the founder of Disney. And that's where Disney came from. I have no clue regarding any of these, what do you call them? The lore behind the movies. But here... Oh, I think I know. T over... This is T plus 1 over T divided by T minus 1 over T. Multiply the reciprocal, this is equal to T plus 1 over T minus 1. That looks a lot better. Yeah, I think I did it right. Therefore, d of dy, let's put it this way, d dt of dy over dx. This is technically dy over dt, and this is dx over dt. This is equal to quotient rule. Quotient rule was top times, oh god, was the derivative of high d low minus low d high. So this is t plus 1 minus t minus 1 over low squared. I hope I remember that right. So this is equal to 2 over t minus 1 squared. Therefore, d squared y dx squared is equal to 2 over t minus 1 squared over t minus 1 over t. So that's 2t over t minus 1 cubed. All right. That wasn't as bad as I thought it would be. dy dx is t plus 1 over t minus 1. D squared y over dx squared is equal to 2t over t minus 1 to the power of 3. I don't like that box. That's a little better. And this was 15. It would seem that I missed the negative sign somewhere. Oh yeah, I forgot the second part of the question. Oh, hang on. So if that's the case, then it was supposed to be low D high minus high D low. That means I did this part wrong. So that's T minus 1 minus T plus 1. And that would give me negative 2. And then this will be negative and this will be negative. and this will be negative. Concave up when when is this greater than 0? When t is greater than 1, it's if t is greater than 1, bottom is negative. If t is greater than 0, top is negative. So top is negative when t is less than 0. Bottom, it's this is -1. No, +1. If greater than 1, this is wait, what? No, negative, positive. So if both positive, both negative, it has to be between these two. It has to be between 0 and 1. So this is concave up when t is greater than 0 and less than 1. This is how I get points off during the test. I just finish a question and I forget about the second half. There we go. Now let's check that again. Seems to be right. All right. Once we're done with, what was that? 15. Let us move on to, how long have I been doing this already? 1 hour. Not bad. 17. Finds the points on the curve where the tangent is horizontal or vertical. Okay, so slope is either 0 or undefined. X is equal to t cubed minus 3t, and y is equal to t squared minus 3. We want to find where dy dx is 0 or undefined. That means let's find our dy dx first. Dy dx is equal to, I should probably write down what the question asked for in these as well. Well, they're kind of self-explanatory. Now, dy dx is equal to 2t over 3t squared minus 3. That means 2t equals 0 or 3t squared minus 3 equals 0. So 2t is equal to 0 when t is 0. 3t squared minus 3 is 0 when t is equal to plus or minus 1. If we put in 0, x is 0. Wait, if top is 0, then we have a horizontal. With a horizontal tangent, plug in 0, we get 0, -3. Vertical tangent, we get, let's rephrase the question. I realize I should have been writing down what the questions ask for. Horizontal and vertical tangent. Plug in -1, you get 2. Plug in -1, you get -2. Plug in 1, you get -2. Plug in 1, you get -2. Straight. So there we go. 1 second. This looks to be correct. Next up, number 19. 19, same thing. We have x is equal to cosine of theta instead of t this time, and y is equal to cosine of 3 theta. We find horizontal and vertical tangent. I could do this. Aha! Less writing for me. dy dx is equal to -3 sine of 3 theta and negative sine of theta. So it's just 3 times sine of 3 theta over sine of theta. The top is 0 when t is 0 or pi over 3 or 2 pi over 3. 2 pi over 3 and 0 would be the same though. Hang on, wait, yeah, 2 pi over 3 would be the same. Down here we have t equals 0 or pi. Yeah, sine of pi is 0 or 2 pi, but 2 pi is same as 0. So for that we have horizontal tangent at, wait, why do I feel like this wouldn't work? If we plug in 0, we get 1. And gone. Plug in 0, we get 1. And 1. Plug in power 3, we get, yeah, no. It can have a, I remember right now, it can have a horizontal and vertical tangent at the same point. So 1, 1 would not work. We have, but wait. If that's the case, then 2 pi over 3. Oh yeah, 2 pi over 3 would be different. And then we would also have 3 pi over 3, but no. 3 pi over 3 would be pi. Then 4 pi over 3, 5 pi over 3, so on. If we plug in pi over 3, we would get cosine. Cosine is x. of 60 degrees, that's 1/2. Barely remember my unit circle. And then cosine pi is -1. And if we plug in 2 pi over 3 or negative pi over 3, we would get -1/2. Wait, no. No, we still get 1/2. And plug in here, we still get -1. So that gives the same answer. What about negative pi over 3? Or 4 pi over 3? 5 pi over 3? We would have 3 pi over 3, but that would not work. And then 6 pi over 3 would just be 0. So no 0. No 3 pi over 3. 4 pi over 3 would give us -1/2. Yeah, -1/2. And then 4 pi -1. Wait, no. I'm getting confused. Wait, 4 pi over 3. Huh. Cosine of 4 pi would be 1. Because of plus or minus 1? No. Was this supposed to be plus or minus 1? It would kind of make sense since this would be a circle of some kind. Wait, no, it wouldn't be a circle. This is cosine and cosine. It's not sine and cosine. I have no idea what this graph looks like. But just to double check. 2 pi over 3, get cosine 2 pi, which is 1. Yeah, this looks like it. 19. Close. This is 1/2 -1. This is -1/2 +1. It's not plus or minus. What went wrong here? Sine of 3 theta equals 0. That would mean theta is equal to sine of 0 is 0. Sine of pi is 0. So pi over 3, 2 pi over 3, 3 pi over 3, because that's pi, 2 pi, 3 pi, 4 pi, and so on. But why would this not work? Plug into cosine. Cosine of 0 is 1. Cosine of pi is -1. So we got 1, -1. Wait. I guess we include a 5 power 3 too. That would be y, and if we have x, that's 1, 1/2, 1/2. Whoa. What did I just do? I just drew a triangle. So it'd be -1, -1/2, -1/2. So it was this and this. I know it's not these. Why is it not these two? If we plug in 2 pi over 3, sine of 2 pi is equal to sine of 0, which is just 0. And then sine of 2 pi over 3 should be √3/2. Okay, where's my... Let me just grab a unit circle. Did I memorize something wrong? Sine of 2 pi over 3. Wait. Cosine of 2 pi over 3 is -1/2. Wait, oh yeah. Oh my god. Can't believe I did this. Not just algebra, but I can't even trig now. I remembered my unit circle wrong. Damn it. No wonder. Well, there we go. All that because forgot a negative sign in unit circle. But there we go, and it has no vertical tangents because, well, we already eliminated all the possible ones. But that would be correct now. Number 29 is next. At what point on the curve, let's see, 29. At what point on the curve, x is equal to 3t squared plus 1 and y is equal to t cubed minus 1. Does a tangent line have tangent line slope is equal to 1/2. So dy dx is equal to 3t squared over 6t, which is equal to 1/2 t. T equals 1. Is that right? Wait, no, it can't be that easy. I have slope of 1/2 3t squared 6t 1/2 t. Yeah, t is equal to 1. Oh, what's the point? No wonder. Plug in 1, you get 4, 0. And that's right. After 29 comes 33. People are gonna be like, I can't count. Why do I keep jumping around numbers? Find the area enclosed by the curve. X is equal to t cubed plus 1. Y is equal to 2t minus t squared. Area. How do I do this? Remember, area is equal to, I think that's how they did it. From A to B. Oh yeah, I remember now. I remember. Which is equal to go from somewhere to somewhere of hang on, let me read the question again. There's no bounds, so area between curve and x axis. So this would be y times x prime. Anime was created after World War II. Wait, really? I thought anime was a really old thing. So anime is pretty new. So I remember how they wrote this in the textbook was y as a function of y is equal to f of x and x is equal to g of x. But I'm gonna just write it as y times, you know what? It's literally y times dx. Damn. Anime is old. So, if anime was created after World War II, what was the first anime? You know that? I'm actually curious now. So anime is a relatively new thing. When did they get the idea to start making anime? So when y is equal to 0, t is between, this is a parabola, so it only touches 0 once. 3 tails. 3 tails, I need to see. 3 tails. What is this about? Oh, it looks black and white and looks pretty simplistic. What was the differentiating thing between anime and cartoon? aside from where it was created. Is there any real difference? Because nowadays, art style, it looks pretty different. But by the looks of it, the Three Tails thing, that's just black and white, simplistic art style. It looks exactly like a cartoon. Or it looks exactly like what an old cartoon would look like. T is going to be 0 and 2. So we know our bounds are going to be between 0 and 2. Because those are the only times T touches, or rather Y touches 0. So this is going to be 2t minus t squared. The first one before 1960. All the way in 1917, blunt sword. Let me search that one up as well. Namakura katana. Oh damn, this is real old. Wow, there's a lot of history here. But when did the first... Okay, no. The more I know, the more question I ask. If I keep thinking, I'll never get this done. I was about to ask if that's when the first anime came from. Where did the first cartoon come from? The questions just never end. And I need to stop asking them. Right, that's dx. Or rather, dt. Because this entire thing is dx. And this is y. Therefore, that's equal to the integral from 0 to 2. Oh yes, I'm familiar with this now. Times 6t cubed minus 3t to the power 4 dt. So this is equal to 3 over 2 t to the power 4 minus 3 over 5 times t to the power 5 from 0 to 2. Plug in 0, you get 0, so plug in 2, you get 224 minus 32, 96 over 5. What is that? 24 minus 96 over 5. I think that's fine. Oh, is it 24 over 5? Calculator. Yep. This is 24 over 5. Oh, welcome back, Pernicious Bunny. I'm surprised you're awake this early in the morning. Did you get any rest at all? There's the anime that got banned. Shoujo Tsubaki. A girl and her mother died of sickness. Quite disturbing. Banned as early as 1992. Just woke up. Okay, that's cool. I did not sleep. I never sleep. 41. But hey, once I get done with this, I'm planning on doing a little Minecraft stream because I was not able to stream earlier this week. 1 plus x is equal to 1 plus 3t squared, and y is equal to 4 plus 2t cubed. 0 t is between 0 and 1. And we want to find arc lengths. The formula for arc lengths should be integral from a to b of square root of y prime squared plus f prime squared dt. Yeah. And this time we want... What is the question here? We want integral from 0 to 1 of the square root of 6t squared to the power of 2 plus 6t to the power of 2. Pokemon, yes, I do know Pokemon. Never played it, but it's such a popular franchise that I know a bit about it. Integral from 0 to 1 of square root of 36t to the power of 4 plus 36t squared dt. What is that equal to? 6. There's a very eye damage from Japanese viewers. And I have no idea what that word means. I assume it's probably Japanese. Times 6 times integral of 0 to 1 of square root of t to the power of 4 plus t to the power of 2. I can factor out another t squared. So the 6 times integral from 0 to 1 of t square root of t squared plus 1 dt. Is this going to be trig substitution? No, there has to be an easier way with u sub because there's t outside. So if I do u is equal to square root of t squared plus 1. Hang on. Wait, what am I doing? The derivative of t squared plus 1. There's an episode called Dino Senshi Oregon, a banned one. A Pokemon episode got banned? Really, Pokemon? Damn. I did not Pokemon episodes even got banned. I know that they have a lot of really weird cultural censorships where they replace random objects with objects that don't make sense. And it causes seizures. Holy crap. Even Pokemon is dark. Times 2t. Okay. So this would be equal to 3t t squared plus 1. Can be split into mimic. Oh, Mimikyu. And is it a mimic? Oh, Q from the end of Pikachu? Mimikyu. Is that like a morphing Pokemon? Is it like, what's the name? The slime one, the purple slime. Ditto. Ditto was the one. Isn't that one that transforms? Is this another one? Because I've never actually heard of Mimikyu. So this is equal to 6 times 1/3 t squared plus 1 to the power of 0/2. Mimikyu disguises as Pikachu. So that's pretty interesting. Very dangerous. So let me actually find that. Mimikyu. What does it look like? Oh, it's like a creepy Pikachu. It's like a sock puppet Pikachu. Okay. This looks pretty hilarious. Sock puppet Pikachu. You can't actually look at it without the disguise. It takes it off and it just deals psychic damage. Plugging 0, no, plugging 1, you get 2 times 2 to the power of 0/2. Plugging 0, you get what? That's one. Okay. So if you see its real form, you get a disease. Good to know Pokemon hides creepy things in their game too. Square root of 8 minus 1. Hang on, this is 41. For square root 2 minus 2. Oh yeah, it is the same thing. I can factor out a 4 innate. I can factor out a 4 innate. What I know about is... I forgot what it is called. It's like a species of Pokemon going extinct and then turning into ghost Pokemon. That's one that I have a little bit of recollection about. Otherwise, I don't know much about Pokemon. But next up is 43. 43 is another arc length. X is equal to t sine t. Y is equal to t cosine t. From 4 souls to 100 souls trapped in a rock. Oh man. I mean, the very concept of Pokemon itself is using wildlife to fight each other. That by itself is pretty dark. I don't know why it would be considered normal. And this one also wants Arclins. Wait. Yeah, Arclins. Arclins, we have y primed is equal to cosine t minus t sine t. X primed is equal to sine t plus t cosine t. Y prime squared is equal to cosine squared t plus t squared sine squared t. X prime squared is equal to sine squared t plus t squared cosine squared t. Y prime squared plus x prime squared is equal to cosine squared t plus sine squared t plus t squared sine squared t plus cosine squared t, which is equal to 1 plus t squared. How convenient. Therefore, the interval from 0 to 1 of 1 plus t squared and a little hook at the end of the t dt is equal to t plus 1/3 t to the power 3 from 0 to 1, which is equal to 4/3. Wait. No. I think I've done something very wrong here. Oh yeah. I forgot one key thing. Suddenly realizes we want integral from 0 to 1 of square root. I forgot the square root, 1 plus t squared. And that makes things that much worse. That there's a Pokemon that cannot stop bouncing, or it's hard to stop and it will die. Pokemon has a lot of weird ways to torture animals. Oh god, how do I integrate this? How about trick sub? One plus is a secant. 1 plus tangent squared is equal to secant squared, right? Yeah. Which means, how do I put this? T is equal to tangent theta. Dt is equal to secant squared theta. So we have interval from 0 to 1 of 1 plus tangent squared theta secant squared theta d theta, which is equal to 0 from 1 to 0 of secant cube theta. Once again, I don't remember this one. It should be 1/2 times secant tangent and natural log of secant theta plus tangent theta, if I remember that correctly. I'm gonna look it up. This is something I'm supposed to memorize, but I think this is what it is, but I'm gonna double check. Oh, forgot a plus sign. Can't believe it. I was so close. I forgot a single plus sign out of this long thing. Forgot a single plus sign. But that also means we get an answer. It's no longer from 0 to 1. It's from summer to summer. If t is equal to tangent theta, tangent is opposite over adjacent, so that's t, that's 1, and that's 1 plus t squared. And this goes from summer to summer. And that means it's equal to 1/2. Secant is hypotenuse over adjacent. Wait. Yeah. Times tangent, which is t, plus natural log of this thing, plus t. Goes from 0 to 1. Plugging 1, we get root 2 plus natural log of root 2 plus 1. And plug in 0, we get 0 plus natural log of 1, which is 0. So this is it. Is that right? Textbook? 43? 1/2 root 2 plus 1/2 natural log of 1 plus... Yeah, this is correct. This is correct. Next up, 61. X is equal to t cubed. Y is equal to t squared. T is between 0 and 1, which is very convenient. I like nice numbers. Surface area of rotation. Oh no. They just said it was nice, and then it tells me it wants surface area of rotation. Oh, fine. Surface area of rotation is equal to 2 pi from A to B of y times the arc length, which already said was y prime squared plus x prime squared dt. Ugh, just looking at these gives me nightmares. So let's try that. Y primed is 2t, x primed is 3t squared. Did I write it right? T cubed, t squared between 0 and 1, yeah. So y prime squared is equal to 4t squared, and x prime squared is equal to 9t to the power 4. Take square root of that. Well, integral from 0 to 1 of y, which is t squared times 4t squared plus 9t to the power of 4. Oh, 2 pi. Don't forget that. 2 pi Oh, equal to 2 pi times integral from 0 to 1 of factor out the t, we get t cubed square root of 4. Can I say 2 squared plus 3t squared? You'd rather have 2 pi's? But do you know that if I have 2 pi's of a pi, you actually only have 1 pi? Because 1 pi is actually half of a pi. I just made up a math joke. But oh my god, what do I do from here? This looks positively disgusting. Do I have to do another trig sub? Because you see, 1 pi is 180 degree, which is only half of a pi. So if I have 1 pi of a pi, you only have half a pi. Oh god, that's gonna be a new tactic that these pi merchants are gonna scam you with. They're gonna sell you a pi, but they're only gonna give you half of it. I'm giving them too many ideas. We factor out a 2. Next time they sell you pies, you better be careful. Ask which pie it was. Don't let them give you the wrong pie. Glad I could make you laugh. But we factor out a 2 squared. We get this. Which means... doesn't really make things better. It's still just as bad. T cubed 1 plus 02 t squared. Now what if 3 over 2t is equal to tangent theta? I hate this more by the minute. Then dt would be equal to 2 over 3 secant squared theta. You're gonna fight someone if you get a pie, French silk pie. Oh god. Too many pies, too many pies. But did it do this right? By the looks of it, yes. T is gonna be 2 over 3 tangent theta. Therefore, is equal to 4 pi from 0 to 1 of 2 over 3 cubed tangent cubed theta, the square root of secant, hang on, yeah, secant squared theta, secant squared theta, d theta. Wait, did I write d theta earlier? Yeah, I did. Why am I panicking? Oh boy. This is then equal to 32 over 27 pi times integral from 0 to 1 of tangent cubed theta secant cubed theta d theta Oh my god. You have to head out. Good luck with whatever you need to do. What is that, school or going out for an interview? Good luck. Hope your rest was good because I do not sleep. Now, 20, what do I do from here? How do I solve this? Tangent cube theta. Secant cube theta. See ya. This is most certainly solvable, but I just do not remember how to. Derivative. Secant is an odd number, so we probably want to do secant something. Because if u is equal to secant theta, wait. This would be integral of, if it's tangent theta, this would be, I don't know, is this solvable? Did I do it right at all? Do I take out tangent or do I take out secant? Wait. Forgot something. There's a 2 over 3 here. Forgot the 2 over 3. So that's supposed to be a 4. 4 times 2 over 3 to the 4th power. Now, tangent cubed, secant cubed. I genuinely do not remember how to do this. We take out secant squared. Yeah, no, mine is not working. I'm gonna get some help. $61. The answer does look pretty complicated. Do I take out secant or do I take out tangent? Oh yeah, I take out secant. Okay, I remember now. So this integral from 0 to 1 of secant squared minus 1 times secant squared theta times secant theta tangent theta d theta. Why does the question need to be this long? Coordinate geometry? I hate it too, but this is not geometry. This is actually calculus with parametric curves, which just goes back to regular calculus. Now, we have u is equal to secant theta. So this is equal to 4 times 2 over 3 to the power 4 pi times 0 to 1 of u to the power 4 minus u squared du, which is equivalent to 4 to the power 3 to the power 4 pi. Oh wait, this is not from power 1 to 2. We don't know what power does this. We don't know where this goes. It goes from somewhere to somewhere. This is in fact coordinate geometry. Maybe that's what it's called. Maybe that is what it's called. But the only name I know is just calculus, trigonometric substitution, u sub. This is 1 over 5 u to the 5th power minus 1/3 u to the 3rd power. Calculus is applied in coordinate geometry. Okay, that would make sense because even in parametric, we are graphing on a Cartesian plane. That would make sense. So this is... Write out all that again. 1 over 5 secant to the power 5 theta minus 1/3 secant to the power 3 theta. Oh wait, there's no du. Or somewhere to somewhere. Now, tangent of theta is equal to 3t over 2. Coordinate geometry is a plotting of curves and lines. Calculus helps with that. That makes sense. We did do graphing in the previous chapter. We are doing parametric curves. This is 4 plus 9t squared. I know it doesn't look parametric right now, but I promise you it's parametric. It's just really ugly. To the 5th power. If this question ends up being wrong, and I just did all that work for nothing. Now this goes from 0 to 1. Tangents, secant stuff shouts trig to me. Triangles, circles, trig. But it was just a necessary step to solve for this integral. We're actually doing surface area of rotation of parametric curves. Which, oh my god. This single question is longer than the entire previous chapter combined. I hate this. And plug in 1. Get 13. Minus... Ooh, plug in 0, we get 2. To the power of 5, that's 32. over 5 minus 8 over 3. Before I even try to simplify this, I am going to check the answer. That does not look right. That doesn't look right. That does not look good. If I messed up a single step in this, I would not be able to tell right now. The answer is 2 over 1215 pi times 247 root 3 plus 64. Which I have a 13 here, so I don't know. I don't think my answer is right. Rotate about the x-axis. I think it started out correct. No. No, I do not want to go through this again. This took me half an hour. Squared backed out a t. Fact out a 2. Yeah, that's good. Did put the 2 out here. I have an idea. I'm gonna toss this integral into calculator. That way I know if I set up something wrong or whether I just did another algebra mistake. But this is gonna take me a while to type. I'm gonna start from the top one here where I didn't simplify anything. Goes from 0 to 1. Meanwhile, I'm gonna see what this answer is equal to. I don't know why they're making me do this. Hang on, 2 over 1215 pi 247 square root 3 plus 64. Seems to be around 2.5. I study computer science, programming, cybersecurity, that sort of stuff. But interesting that the answer is in fact different from the calculator solving my thing. Let me read the question again. Y is equal to t squared. That's right. Dx squared, dy squared. That's right. CTFS? Not really. But oh my god, what is wrong here? Cannot tell what is wrong. Also, I will say there are times when the textbook is wrong. There has been 2 cases so far. CTFS. Oh, okay. Sounds pretty interesting. Right now, I'm still mainly just doing what, A+. I already finished A+. I'm working on just Cali right now. I am working on pen test. But where does this go wrong? Now let me actually find the, let's solve mine. 4 times 2 over 3 to the power 4 times pi times, you know what? I better use an actual calculator for this. Oh, you're into cybersecurity too? That's awesome. That's awesome. Let's see. 4 times 2 over 3. Huh. What is it? 2 over 3 to the power 4 times pi. Where's pi? Times 1 over 5 square roots 13 to the power of, hang on, 13 to the power of 5. Electronic and communication engineering. That's cool. Divide by 5. Minus square root of 13 to the power of 3 divided by 3 minus 32 over 5 minus 8 over 3. Yeah, no. More differential equation, domain transforms, and probabilities, and coordinate geometry. Oh, we also do differential equations here in calculus. Let's see. Yeah, my answer does not really make sense at all. Where does this start going wrong? Where is this going wrong? This hurts. Doing this for half an hour to find out that your answer is wrong. Oh my god. So I didn't have to do trig substitution at all. Okay, maybe I'm just dumb. What happened here? Where does this U sub come from? Let's see. If I follow their steps, right here I would have two pi 0 to 1 of t cubed 4 plus 9t squared. U is equal to, let's just say 9t plus 4, no, 9t squared plus 4. Du would be equal to 18t. AT&T. dt would be equal to 1 over 18 du. Oh, this is not t. This is dt. So we will get... Oh, wait. What's t equal to? Huh? What? Not for the image, I'm just very confused. Oh, wait. Wait. I think I see. Made a slight mistake. U is equal to 18t dt. So dt is equal to 1 over 18t du. So t squared is equal to u minus 4 over 9. But would that really help? It kind of would. This could be how they got to it. Which means... Wait. Wait a second. 1 over 18t, so we would have 2 pi 0 1 t squared u. Let's say t cubed for now, and this is 1 over 18t du. Transform that completely, we would have 2 pi from 0 to 1 of u minus 4 over 9 times square root of u times 1 over 18 du. I see. And now we have 2 pi. So that's pi over 81. Wait. Yeah, okay. They didn't do it this way. I can do it this way. From 0 to 1 of u to the power of 2 over 3. Or rather, u to the power of 3 over 2 minus 4 times u to the power 1/2 du. Which is equal to 31 from, or rather, we can solve it now. 2 over 5 u to the power of 5 over 2 minus 8 over 3 u to the power of 3 over 2 from somewhere to somewhere. Actually, once we do the u sub, we can't have these anymore. Put t back. (90 squared plus 4 to the power of 5 over 4 minus 8 over 3 9t squared plus 4 to the power of 3 over 2 from 0 to 1. But that is by itself just wrong. Could I have set up this not properly? Y prime is 2t. This cannot be. Pi over 81 times, plug in 1, you get 2 over 5 times square root of 13 to the power of 5 minus 8 over 3 square root of 13 to the power of 3 minus square root of 4 is 2 to the power of 6 over 5. So that's 64 over 5 minus square root of 2 to 64 over 3. Still doesn't quite look right. What went wrong here? U pi this 81, yeah. This part's right. Make this a little bit clearer. Minus 8 over 3. Or this part's fine too. So this is right. This is solved correctly. Why does this look different? Is it because I simplified? Or is this the same number? Just looks different. Let's solve it. Pi divided by 81 times 2 times square root of 13 to the power 5 divided by 5 minus 8 square root of 13 to the power 3 divided by 3 minus 64 over 5 minus 64 over 3. Wait, this is right. This is what I got. So scratch all this. Where did it start? Scratch all this. But this is still different from the answer in the textbook. Why? Two by 1215 times pi times 247 square root 3 plus 64. I don't understand how the textbook got you that answer. This does not make sense. I don't like this. I'm scared. Did I get the formula wrong? The only explanation would be I somehow got this wrong. 2 pi y is t squared. Y prime is 2t squared. We get 4t squared plus dx is 3t squared. Square that, you get 9t to the power of 4. I don't understand. What is wrong here? This hurts. But I'm gonna go with my answer. This wouldn't be the first time that the textbook is wrong. So let's go to 63. That's pretty big writing. 63. Go to 100% zoom. 63, we do the same thing except this time x is equal to a cosine cube theta and y is equal to a sine cube theta. Theta is going to be between 0 and pi over 2. inclusive. Find surface area. Rotate around x-axis. Y prime is going to be equal to a times 3 sine squared theta cosine theta. X prime is going to be equal to a times 3 cosine squared theta negative sine theta, so negative. Okay, square that. Y prime squared is equal to 9a squared sine 4 theta cosine squared theta. X prime squared is equal to 9a squared cosine 4 theta sine squared theta. Square root of x prime, or rather, let's do y prime first, doesn't matter, plus x prime squared is equal to 3a times square root of sine 4x. We can factor out a sine squared. 3a sine theta cosine theta square root of, we took out a cosine theta, so we get sine squared theta plus cosine theta. No, plus cosine squared theta. Wait. That cancels out perfectly. See, this is what the problem should be like. Cancels out so nicely. So we want the integral from 0 to pi over 2 times 2 pi of y a sine 3 a sine cube theta times 3a sine theta cosine theta d theta. That's going to be equivalent to 2 pi. We can take some more terms out. How about 6 pi a squared? Since a is a constant, right? Integral from 0 to 2, no, pi over 2 of sine to the power 4 theta times cosine theta d theta. And we have to say u is equal to sine theta. This is equivalent to, du would be equal to cosine theta d theta. This will be equal to 6 pi a squared. The whiteboard's lagging now. I've written too much on a single board. Of u to the power 4 du, which is 6 pi a squared times 1 to the 1 over 5 u to the power 5. Oh wait, once we do the substitution or bounds change, we don't know where it goes. But this is equal to 6 pi a squared times 1 over 5 sine 5 theta from 0 to power 2. Plug in 0, you get 0. Plug in power 2, you get 6/5. Why did I correct that? 6/5 pi a squared. Is that right? Please tell me yes. It's correct! This one was easy. This one was nice. I like this question. Whew. But why was this one so darn difficult? Look at this one, how short that is compared to this mess. I still don't know what's wrong here, but frankly, we don't need to know because this part, right? I don't know how the textbook got their answer. I'm gonna stick with my answer. But that means 10.3 has to be a little bit off to the side. About here. Make sure it does not... Ooh, never mind. It needs to go even further. Move over. Make sure they're on the same line. Oops. Yeah, this is fine. Actually, is 10.3 even gonna be that long? Oh yeah, looks like 10.3 has quite a few problems. But 10.1 through 10.2 has been about parametric equations. 10.3 we have polar equations. I might need to start a new whiteboard because there's an incredible amount of lag just from writing normally. What if I disable this? Would that make it better? Seems like it. It seems like there's going to be quite a bit of curve sketching. So starting with 11, 2 is less than r, which is not less than or equal to. 2 is less than r, which is less than 3. That lag. And 5 pi over 3 is less than or equal to theta. That's equal to 7 pi over 3. I don't know, there's a lot of lag going on. Microsoft could optimize their whiteboard a bit more. Maybe not load everything that's off screen. That could make performance a lot better, yeah. But here we go again, drawing graphs. We need at least 3 units. Yeah. Okay. There we go. R is between... Let's find the angle first. 5 pi over 3. It's 7 pi over 3. 7 pi over 3 is just pi over 3. That's 30 degrees. 30 degrees out. Goes out 30 degrees. It doesn't look like 30 degrees. That's fine. Well, wait, no, not 60. No, not 30. 60. What am I saying? 5 pi over 3 just looks like negative 60 degrees. So we want 2 and 3. So this is 1. This is 2. 1, 2, 3. We also are exclusive, so we have dotted lines. Oh my god, this is such a terrible graph. but we fill in this area here. Does that make sense? This is such a terrible graph. But there it is. That's a pizza crust. If you cut pizza into 6 pieces, that's 2 pizza crust. Is that all numbers 11 ones? Oh yeah. Next up is number 17. 17 says r is equal to 5 cosine of theta. Identify the curve by finding a Cartesian equation for the curve. Oh, I should probably write down a couple things. Let's move this all down, because a couple of things are going to be relevant throughout this entire chapter. That should be enough space. What I want to write down is... Stop. I can't do anything. It's stuck. Okay, it's back. Need to finish this before Microsoft Whiteboard decides to crash on me. X is equal to r cosine theta. Y is equal to r sine theta, you guessed it. Or Pythagorean theorem, x squared plus y squared equals r squared. Tangent theta is equal to opposite over adjacent, which is y over x. There we go. So we simply gotta match this to one of these. So this one, you probably have to multiply r to both sides. So 5 r cosine theta. That's x squared plus y squared, because r squared is equal to x squared plus y squared times 5. R cosine squared is x times 5x. There you go. Do I want to simplify? You could simplify it. Yeah, no, I'm not gonna go bother completing the square for this. It is what it is. No. Oh wait, identify the curve. Oh no. What is this curve? Guess we do have to do it. X squared minus 5. Actually, x squared minus x. No, wait, no. What am I doing? X squared minus 5x. Wait, what am I doing? R cosine, no, r equals 5 cosine theta. Mine's going down for a moment. Multiply r to both sides. R cosine, that turns to x. X squared plus y squared equals 5x. What kind of graph is this? X squared plus 5x, no, minus 5x. Plus y, rather, plus 2.5 squared plus y squared equals 2.5 squared. This is a circle. This is a circle, 100%. X minus 2.5 squared plus y squared equals 2.5 squared. It's a circle with radius. I cannot write anymore because of this lag. Radius 2.5. Centered at 2.50. Yes. Yes. Now, 17. We have, after 17, we have 19. How many questions do I have? Oh God. Oh God. I don't know if I will make it in time. 19 says r squared cosine 2 theta is equal to 1. That means r squared cosine 2 theta, that's sine squared theta. No. What is it? Cosine squared minus sine squared. No. That's 1 plus sine squared? Is it? No, it's minus, right? Wait. Let me just look it up. Cosine 2x is equal to... Oh, I got it completely wrong. Y minus... Let's do cosine. 2 cosine squared x minus 1. I got this one completely wrong. I knew it was cosine squared minus sine squared, but I don't know what I did after that. Cosine squared theta minus 1 equals 1. So 2 times r squared cosine squared theta minus r squared equals 1. R cosine theta is x, so 2x squared minus x squared plus y squared equals 1. So x squared minus y squared. Oh, welcome back, Arnable Coca. You're up really early in the morning. Is equal to 1. No, I'm just here because I procrastinated till the last minute. Is that right? This is a hyperbola. And it opens this way. Ew, hyperbola. I know, right? Is that right? I should probably graph it. How do you describe a centered at 0, 0. Wait, no. Oh, I forgot all the terms you use to describe origin. Origin's the word. Thank you. I'm sure you are. You're just good at a vastly different kind of mass because there's so many types of mass. Let's see here. X squared minus y squared equals 1. Let me graph it real quick. Yeah, I was right. Wait. Yeah, I have no idea how you describe a hyperbola, so I'm not gonna bother trying. It has been so long since I've seen one of these. They're like ancient antiques. Y is equal to 2. Over the previous two questions, we were doing find Cartesian. This one was graph. This one's find Cartesian. I should probably also say opens horizontally. Looks like this. I think that's where they came up with the basketball lines. That's how they make basketballs now. But anyways, number 21, instead of finding Cartesian, this one says find polar. Find polar. So r sine of theta is equal to 2. R is equal to 2 over sine theta. It's that easy. Now, 23. Y is equal to 1 plus 3x. Oh, a little bit of context on how I'm just randomly doing all these things. X is equal to r cosine theta and y is equal to r sine of theta. Like, if you remember these 4 things, you're good to go with everything. Everything in this chapter is gonna be easy. But good things don't last long. It's probably gonna get real difficult real soon. So y is r sine theta. That's equal to 1 plus 3 times x is r cosine theta. Yeah. Probably want to separate r by itself. But how can we do that when there's a 1 here? R sine theta minus 3r cosine theta equals 1. R is equal to 1 over sine theta minus 3 cosine theta. There we go. There's the polar graph. Now, 29. R is equal to -2 sine theta. And it says graph in Cartesian. Let's draw a graph here. Oops. Straight line. Look at how perfect my line is. Definitely hand drawn lines. So x squared plus y squared is equal to -2y. Hang on a second. Oh, I know where this is going. If you divide by half, that's how much the circle is going to move by. So if we simplify this, it's definitely going to turn out to be y minus 1 squared. Hang on, what's the radius? Plus x squared. Radius is 1, right? And radius would be 1. So this is a circle that's been moved down 1. Let's say that's -1. We just draw a circle around it. There we go. This is -2, 0. There we go. Is that right? Yeah. Hang on. 2 3 power 2. Yeah, that's right. 30. Wait, no, 31. We're only having odd number questions today. That's nice. R is equal to 2 times 1 plus cosine theta. Okay. R is equal to 2 plus 2 cosine theta. This is going to be a cardioid. This is going to be a cardioid. Let's say this is 0. It's going to be centered here. Because plug in 0, you get 4, 1, 2, 4. Plug in power 2, get 2. Hang on, yeah. And plug in pi, you get 0. It's gonna look something like this. Something like this. That's such a terrible graph. Let's try that again. All right. This is such a terrible graph. But next up is 35. 35 says R is equal to 3 cosine 3 theta. So these are all graph Cartesian. Wait, wrong lens. Hey, hello there, pizza cats. How's your morning? Are you here for some suffering? Well, 3 cosine 3 theta. I pretty much know what this is gonna look like already. It's gonna have a length of 3. 1, 2, 3. And there's a 3 theta, so it's gonna have 3 leaves. Because if you plug in pi over 3, you get 0. Plug in negative pi over 3, you get 0. How long have I been doing this? Good question. It has been 3 hours, 2 minutes, and 43 seconds exactly. Looks like this. And I'm gonna have 2 more leaves over here. Of mass, yes. Delicious mass. But this is gonna look... I don't know how to draw this. Don't judge me for drawing this. Good enough, good enough. I've already spent way too much time today. Anyways, after 35, we get to 39. Is that graph right? Yeah, that looks right. Oh, let's put a point. This point here is 3, 0. '39 says r is equal to 1 plus 3 cosine of theta. And it still wants you to graph. This is going to be another cardioid that collapses in on itself. Now, and whoop. Why do I always make the bottom one short? 3, 1, 2, 3. It's gonna start here, and this is gonna be an inner blob. This is gonna be the outer blob. I can't draw. So there's gonna be an inner one and an outer one. Outer one, like this. I do speak Chinese. Not very fluently, but I can speak it and understand it. Wait, actually, no. So the outer one goes all the way at 4. Outer one. One more try. Good enough, good enough. Why Chinese? I don't know either. I just know how to speak it. Can't write though. For some reason I don't know how to write in Chinese. Now, once 39 is done, we can move on to 43. For these 3, it does the same thing, except this time r is equal to 2 plus sine of 3 theta. Graph Cartesian. I can feel the whiteboard lagging more and more. Let's see. What will this look like, I wonder? It's also going to be a cardioid. This one's going to face up. And it's going to collapse in on itself just a little bit. It's going to start at 1, 2, 3, 4, 5. Collapses in on itself at most 1. So there's sort of inner little blob. There's an outer one. Every time I try to draw a curve, I hate myself just a little more. It starts at 0, 5. Yeah? Wait. No. Drew the wrong thing. I thought it was 3 sine theta. This is sine 3 theta. Wrong thing. Plug in 0, you get 2. This is gonna be something that looks kind of like this with 3 leaves. Plug in pi. If we plug in pi over 3, but 0, that's here. Why math? Because math homework, well, not that fun, is the most fun homework out of all the other subjects. Plug in 0, you get 2. Plug in power 3, you get 5. Power 3, 60 degrees. About this way, go 1. Just say this is 5. Let's just say here. This is going to be pi over 3, 5. It might not look like it, but this is. It is my homework. Now plug in 2 pi over 3. Again, 2. 2 pi over 3 at 60 degrees. 120 over here. We get 2. 3 pi over 3. Wait. 2 pi over 3? We get, yeah. 3 pi over 3, we get sine of pi, which is 0. 2 pi over 3, we get sine of what? Hang on. Brain not functioning. Brain not functioning. This is not 5, this is 3. And sine of pi, how do I get pi over 2? Sine of pi over 6. So we need a pi over 6. 3. That's 30 degrees. Not over 3, over 6. 30 degrees out by 3. I mean, R goes first. Pi over 6. Plug in pi over 3. You get 2. We plug in pi over 2. This is weird. Plug in. What do I plug in now? Pi over 3. Get 2. If we just plug in pi times 3 pi is 0, we'll get 2. Plug in how many pi over 3? If we plug in 2 pi over 3, we get 2. If we plug in 3 pi over 3, that's just pi. Wait. Plug in 2 pi over 3, we get 2. Plug in pi over 2, we get sine of 3 pi over 2. Sine of 3 pi over 2 is -1. 1. Oh, I know now. It goes like this. Like this. I need one more point here. This is gonna be what? Something 1. I don't know, but this will be what it looks like. And like that. This is my best guess because I don't want to plot more points. We have a point at 1 pi over 2 at our smallest, and 3 pi over 6 at the largest. Yep. Hooray. Almost there. After 43 comes 57. R is equal to 1 over theta. Theta equals pi. Find tangent. Or rather, just find slope. Okay. dy dx is equal to, what is it? F prime theta. There is a way to derive it from r cosine theta and r sine theta. This is F prime theta sine theta plus F theta cosine theta over F prime theta cosine theta minus F theta sine theta. This comes from R. Let's put it here. R equals F of theta. R has to be equal to f of theta. So this is r cosine, no, r sine theta. R sine theta over r cosine theta. Yeah. So you see, there's y, there's x. Takes a derivative, you get this thing. Take a derivative, you get that messy thing. Let's move it around a bit. It takes a derivative of r cosine theta over the derivative of r, wait, wrong one. Y is sine, x is cosine. And that is equal to that long thing. Make it look a little bit better. Please, just, oh my god. Select. Move. Okay. Slag. But there we go. All right. So we got f, or let's say r primed is equal to negative theta to the power of negative 2. Wait. Negative 1/2 theta to the power of negative 2. Wait, no. I was right. Negative theta to the power of negative 2. So dy dx is going to be equal to negative sine theta over theta squared plus cosine theta over theta over cosine theta, rather negative cosine theta over theta squared minus sine theta over theta. Plug in pi, we get sine of pi is 0. We got 1 over pi top, we get 1 over pi cosine, wait, cosine pi is negative 1, we get negative 1 over pi over cosine pi is negative 1, we get 1 over pi squared, and that's 0, and that's equal to negative pi. Is that right? This is 57. This is correct. Not too bad. 59. 59 says r is equal to cosine of 2 theta. Theta is equal to pi over 4. Oh boy. All right, R primed is going to be negative 2 sine of 2 theta. So dy dx. Why do I feel like my pen is too thick? Was it always at 3? Oh, I'm really zoomed in. I am so sorry. Is equal to negative 2 sine. Let's move it up a little so I can still see it. 2 theta sine theta plus cosine 2 theta cosine theta over negative 2 sine 2 theta cosine theta minus cosine 2 theta sine theta. Sine of pi over 2 is 1. We get negative 2 times sine of pi over 4. Give me a second. Sine is y. Sine of pi over 4. Wait, just root 2 over 2. So we got negative root 2 plus cosine of pi to 0. So negative root 2 over cosine to cosine, that's 0. Negative 2 times thing gone. 1? Yeah, it's 1. There we go. Yeah, this is also find slope. And we are on to the last question, Jose. 61. R is equal to 3 cosine theta. Find horizontal and vertical tangents. There's probably no such thing as tangent points. Let's just say tangents. Well, it would be more descriptive to add points, because we don't need the line, we just need the points that the tangent line is vertical or horizontal. But that means this is even harder than the previous ones. R primed is equal to negative 3 sine theta. That means dy dx is equal to negative 3 sine theta, negative 3 sine squared theta plus 3 cosine squared theta over negative 3 sine theta cosine theta minus 3 cosine theta sine theta. Yes. Factor out as 3, we get this is equal to cosine squared theta minus sine squared theta over negative 2 cosine theta sine theta, and that's equal to cosine of 2 theta. Wait, is that right? I think so. Cosine 2 theta over negative, well, let's put negative out here, sine of 2 theta. For that to be equal to 0, if the top is 0, cosine of pi over 2 is 0, so pi over 4. Or 3 pi over 2, which would be 3 pi over 4. But that's from 0 to pi, so we need to go to 2 pi. Let's see. 3 pi over 4 pi plus pi over 2. Wait. No. That's right. For bottom to equal 0, theta has to be equal to 0 or pi over 2. If it's higher, just makes a full circle. Let's see. Yeah, if we put pi, and there's 2 pi's that goes back to 0. Horizontal, if the top is 0. Horizontal tangents at, ooh, what's the radius? Plug in pi over 4, 3 root 2 over 2 pi over 4. Plug in 3 pi over 4. Negative root 2, right? Negative root 2 over 2. So negative 3 root 2 over 2. 3 pi over 4. Vertical tangents. Plug in 0, you get 3. Plug in pi over 2, get 0. Is that right? That is right. But it has been done. Hooray. How long does that take? Oh my god, that's gonna lag so much when it selects. It's frozen. It's been 3 hours and a half. Microsoft Whiteboard just froze when I did this. I can't move it. Please. I need to move these a bit over to the left. Please let me do that. Move. Oh my god. It's moving. It's moving. That's close enough. It's frozen again. I can't do anything. The Microsoft Wiper is just completely frozen. Come on, I want to see how much I wrote. Just unfreeze for a moment. You can freeze up later when I close you. No, Microsoft Whiteboard doesn't want to respond. But anyways, I have a little bit of time left. I'm going to show off a couple things. I'm gonna launch Minecraft. If it closes, I hope it saves. Because if this doesn't save, I am screwed. I don't want to force close it because I'm afraid I might not save. So I'm gonna leave it there. Come on. Come on. But WoW was 10.1 short. Just a couple of graphs. And then comes 10.2 with the ridiculous questions. But while that's loading, I can start typing up the improvement for this week. I hear the screams of a banshee now. I hear the screams of a banshee. Oh, it's so loud. I'm scared. Is my computer gonna burn? Oh! It's back! It's back! There we go. There's everything that was written down today in the span of 3 hours and a half. But I'm gonna close this stream so the video stops and the VOD goes to another video. And I'll be back in a couple minutes and then we'll have a little quick Minecraft stream. So see ya in a couple minutes. Yeet!